Right, an ornamental garden spike is in the form of a square-based pyramid with a cone attached to the centre of its base as shown below. Okay, so here's your pyramid, here's your cone. The radius of the base of the cone is 4 centimeters, so we put that in there. The height of the cone is twice the height of the pyramid. So we've got height of the cone is twice the height of the pyramid. Okay, so it's not on to scale, but you kind of see it is a bit more, isn't it? So perhaps what I'll do is, if I call this h the height of the pyramid, then the height of the cone will be twice that, yeah, 2h, because that's what it's saying. The volume of the cone is equal to the volume of the pyramid. Calculate the length of the base of the pyramid. Okay, so they don't tell us anything about the volumes, right? They just say they're equal. So perhaps what we'll do is we'll work out the volume of both objects. So we do the volume of the cone first. I think that's looking slightly easier. So 1/3 pi r squared h. So that will be 1/3 times 3.14 times the radius squared. And the radius, remember, is 4. So it'll be 4 squared times the height. Now the height of the cone, it was double the height of the pyramid, so we'll just call that 2h, yeah? That's what it is. Because we need to have that representation. Later on, maybe we need to put the volumes equal to each other. So this is 2h, isn't it? So 1/3 times 3.14 times 4 squared times, of course, then 2. So we times all the numbers. So we get 33.493 recurring and h on the end. Okay, that's the volume of the cone. Now we're going to put this equal to the volume of the pyramid, aren't we? Okay. So let's go for it then. The volume of the pyramid is going to equal to the volume of this cone here, 33.493 recurring h. Okay. Now, what do we know about the volume of a pyramid? Well, remember, a pyramid is exactly like the cone in many ways, right? So they give you the formulas, don't they, for the cone. 1/3 pi r squared h. The pi r squared bit, remember, comes from the fact that it's a circular base of the cone. And it's exactly the same, because this pointy end of the pyramid, it'll be 1/3. But the base now of the pyramid is in a circle, isn't it? Like a cone. Okay, so it's not going to be pi r squared for the base. The base is going to be the area of that base, and it's is it right? Is it a square base? I think it says somewhere, isn't it? A square base. Okay, so we need the area there. Now I don't know the length of this. Okay, don't know the length of it. In fact, that's what they're asking for us to work out, isn't it? The length of the base. But in the pyramid formula, you need the volume, you need the base area here. So if I just call it big capital B there, right, for a minute, right? And of course you times it then by the height, okay, just like with a cylinder, 1/3 base area times height. And that equals to 33.493.h. Now what I can do now, here is no numbers to work out here. I've got this third, remember a third is dividing by 3. So if I take that up there, okay, because I'm dividing by 3, take it up, I'm going to times by 3, okay? So I'll have base times h equals, then do that my calculator, so ants times 3, and I get 100.48, and don't forget this h. Now what I can do, right, there's a couple of ways you can do this, right, because you've got h's on both sides, right, you can actually cancel the h's, right, they will end up cancelling, which is nice. But the other way of showing this, right, because you've got base times h, right, to get base on its own, right, this h I can take over and divide, yeah, because you times them by h, take it over and divide, and then you can see h on the top, h on the bottom, h divided by h, well it is 1, isn't it? H divided by h, something divided by itself is just 1, so they cancel. So you end up having base equals 100.48, right? Now I could have cancelled the h's here, right? I could have done that like that, right? I could have gone like that, because it's times by h on both sides, so you just divide by h, right? They just cancel, but or I could have just taken it over as I've done and cancelled them that way. It doesn't matter. Now remember, now this is the base area, right? B represents the base area, and because it's a square base, okay, the length will be same as the width. So actually the base area is L times L, which is L squared, yeah? Okay, because the length is the same as the width, it's a square, so L squared. So the B is actually L squared. So then to get L, of course I've got to take the square over and do the opposite in square root. So square root the answer, my calculator, and I get this 10.02, okay, or 10.0 centimeters to 1 decimal place. Okay, now part B says the total volume of the spike, cone and pyramid together is 335.1 centimeter cubed. Calculate the total length of the spike from the tip of the cone to the top of the pyramid. So of course the total vol, right, as it's saying here, is this, and that's basically adding the volume of the pyramid and the cone together, yeah? So the volume of the cone is this, 33.493 recurring H, and adding together then the volume of the pyramid. Now it can get a bit confusing, of course, but then if you think about it, they were equal, weren't they? Didn't it not say that the volumes were equal? The volume of the cone is equal to the volume of the pyramid, so really it's another one of them, isn't it? Alright, so all you've got to do then is add these two together, right? So 33.49. Now you don't have to put that recurring thing in, right? You can do it on your calculator if you want. Shift and that button there, it's above the square button. So we're shift first, but you don't have to do it. So you got that. Of course, you want to times that by 2, yeah? Because there's 2 of them. So you just add it to yourself. So you get 66.986 recurring H equals to 335.1, and then to get H, do 335.1, divide by that ounce, so you get, yeah, pretty much 5, isn't it? H is equal to 5, and because you want this whole height of it, the height represented here by H plus 2H, so that'll be 5 plus 2 lots of 5, which is equal to 15 centimeters.